Now, we've all seen our share of 3D animation. At the movies, on TV shows, and in the video games that we may enjoy playing. Have you ever wondered just exactly how they pull all that off? In other words, how 3D animation is actually created? I mean, there's got to be a process or some kind of a workflow to follow, right? You bet. In every animated project, no matter the direction the venture takes or the application it's intended for, there's a very specific step-by-step methodology to working. Every animation begins with a certain concept or a certain idea that you as an animator want to get across. You want to tell a certain story, sell a certain product, demonstrate a certain technique. Makes no difference, each animation will start with a vision. And that vision, normally, in order to stay organized and on track, should be written down. They call that, on paper accounting, a storyboard. And it serves as your roadmap or blueprint to follow over the course of your project. You've probably heard the old saying, plan your work, then work your plan. Well, that's the idea in creating a storyboard. You always want to have your idea or plan sketched out prior to actually making something or beginning to animate whatever you've made. Yeah, the storyboard is work, but trust me, boarding your idea out will do nothing but save time and effort in the long run. In addition to reducing your level of frustration and any possible misunderstandings there may be with others throughout the project. So get that storyboard going. You'll thank yourself once all is said and done. Now, once you have a structured plan in place, you'll begin building the objects that you'll need for your scene. That construction process will have you working in a way that's very similar to how a sculptor molds a piece of clay. The process is typically referred to as modeling, and it works by you basically stretching and pulling a piece of computer clay in order to achieve the look that you're aiming for. The process is very similar to the way that you might have played with Play-Doh as a kid. It didn't matter whether you were making a cartoon character or a car for that character to cruise around in. The creating process always started with a handful of clay that you would then mold into whatever shape you needed. Building things in the computer works pretty much the same way. Now, I am simplifying things a bit, being that there's actually many different techniques that you can use to build things. But in essence, that's pretty much how it's done. Stretching and pulling a piece of digital clay, forming it into the shape you need. Now, once the model's been made, you'll then focus on applying a color or texture to its surface. It'll be that skin, or what is sometimes referred to in 3D lingo as a shader, that'll start to make your objects look more realistic. The overall look of your object's skin will typically be created by using a simple picture that you'll wrap or stamp onto your object's surface. In fact, it's usually a picture of one variety or another that you'll use to control most of your object's surface characteristics. Whether it's smooth or bumpy, dull or reflective, all kinds of different surface attributes can be controlled by the use of a picture. I'll show you how all that works when we get to the chapter on materials. Once your skins are in place, you'll then start concentrating your efforts on controlling the lighting in your scene, which, as you'll come to learn with more experience, can be one of your biggest weapons in creating a certain mood or feel for your work. Unfortunately, lighting is a subject that I've seen far too many new animators underestimate as to its importance in being able to get an audience to react or respond in a certain way to what they're watching. Those newbies apparently forgot how around the days of Halloween, a well-placed light under a friend's chin would make that individual look very sinister and ghoulish, simply because of the position of the light. You gotta always think of lighting as a storytelling tool and use that tool to your advantage. Once your modeling, materials, and lighting are in place, it's time to start moving things around. And this is an area that can so many times keep a person calling animation a hobby and not a profession. It's tough making things move in a way that allows your audience to believe. Yeah, not so hard with maybe a mechanical part moving up and down, but to make a character move in a realistic way, let me tell you, that's a whole nother story. You'll get to doing it well, but it's going to take patience and practice and more practice. Believe me, they pay good animators the huge sums of money they do for a reason. And lastly, one final piece to the puzzle is a process called rendering, which is simply a fancy way of saying that you're going to take a colored picture of the work you've done. Sometimes hundreds of pictures. Yeah, you don't want to leave your efforts on the screen, you want to render your project. So it can go out to print, be burned onto a DVD, or maybe even broadcast over the web. It'll be the rendering process that finishes the job, then allowing others to see and enjoy all your hard work. So that's pretty much the production process from start to finish. Put it down on paper, build it on the screen, dress it up with a skin, throw in some light, get things moving, then finish it off by taking a few pictures. That's pretty much it. And when you get a chance, check out the table of contents to this fundamentals title we're doing here. We're going to be showing you how to do all that in the videos that follow. Let's go check them out. Inasmuch as one doesn't have to be a good artist to be a successful 3D animator, there's no debate that having a foundation built on traditional art concepts and principles is certainly of value. If you're truly serious about the field of 3D animation, whether approaching it as a hobby or career, you really ought to consider the value of getting a little traditional art training under your belt. Even if you never excel at being able to draw, picking up a few techniques that'll help with your design and composition will pay big dividends as you strive to become a better 3D artist. Traditional art training teaches essential concepts and ideas that carry over to any art form, whether drawing by hand, taking pictures with a camera, or pounding something out on the computer. For example, formally trained artists realize the importance of a well-designed image having a center of interest. They understand that proper staging of a scene can make it much easier for their audience to quickly identify the most important elements within a shot. You never want a viewer to simply look where they want to look. No, you want them to be looking where you want them to look. And there's a trick to making that happen, like the proper use of color and light. Formal art training would also give you a better sense of the importance of balance within a scene. You want to make sure that you're laying things out so that no one part of the scene feels any heavier or weighed down than any other area. In addition to balance, you also want to make sure that your scenes aren't too symmetrical. In other words, it's important to mix things up as far as size and proportion. Doing so just makes things look a little more realistic and believable, as will adding a little overlap in your scene. An understanding of proper composition stresses the importance of never having all your objects lined up in a pretty row. It's the overlap that you build into a scene that goes a long ways in providing a little extra depth and three-dimensionality in your work. A little traditional art training would also work wonders to improve your color and shadow, two of the very most important elements in creating realistic work. Traditionally trained artists realize that certain color combinations work better together, for example, whereas other colors that are combined together sometimes clash to the point of making an audience feel uneasy or a little on edge. Think about that. Simply by the way that colors are blended or combined together can determine how an audience feels about your work. It's amazing how something as simple as a color or two can affect their perception and their emotional response. So that's a few things to consider when making the effort to building the best 3D scene possible, one that has interest and intrigue. And don't think it stops there with only a traditional art class or reading a book or two on art in general. You might also want to consider maybe some formal training in photography or film appreciation. There's a lot to know in using the proper camera angle and lens length as you strive to make the most out of the scenes you've created. As I'll be mentioning in our chapter on cameras, a camera, if used correctly, can be one of your primary assets in creating a certain mood or feel for a story. And one last thing I'd like to mention about studying up. I might have left it for last, but this may be the very most important advice I can give you. Whether you do it in a school classroom or on your own, don't watch, but study the way things move, the way objects react and interact with other things. What's the difference, for an example, between the way a beach ball bounces and the way a bowling ball bounces, or a balloon, or a water balloon? They're all round. You make each of them the same way on the computer using a sphere. But each reacts to coming into contact with something else quite differently, right? It's going to be your ability to accurately show that kind of stuff that's going to be your ticket to making a ton of money and retiring while you're still young. So study up. If you're truly serious about becoming the best 3D animator possible, having a rock-solid foundation in traditional art concepts and principles will only make you better. Your goal as a 3D animator will almost always be to create something that looks as realistic as possible. Today's audiences have come to expect an almost realistic quality in order to believe in what they see. They no longer appreciate something simply because it was created on the computer. Oh, those days are long gone. In today's market of feature films, TV commercials, and video games, audiences have gotten very finicky. They want only the best in both computer-generated realism and believability. And in order to create the highest level of authenticity in your work, the kind of stuff that turns heads, you need to do a couple things. First, you need to know your software of choice inside and out. You never want it to be the software or your ability to use the software to be what holds you back. The second thing you got to do is to always do your best to find whatever you can as far as reference material. Something you can copy, something you can replicate. When modeling, adding materials, lighting a scene, making things move, it doesn't matter. Whatever you're attempting to recreate, you almost always will do a better job, a more realistic job, if you have a reference to compare to. And don't in any way ever think that using a reference as a point of comparison is cheating. What it's doing is working smart. I mean, think about it. Don't artists paint from what they see? Don't musicians many times play from what they hear? You as an animator are no different. You study what you can get your hands on, you then recreate what you've learned from that. So if you're attempting to model something, find a real-world object that looks just like what you're trying to make, or at least a picture of that object. If you're applying a skin to a surface in a scene that might look, let's say, like old rusty metal, get your camera and take a picture of something that you can find that has a similar type surface. Just look around. Trust me, it's not hard to find things that are worn out or beaten up. If you're trying to light a scene a certain way, study how the light in your world looks at certain times during the day. Or maybe pull out an architectural magazine, which are always filled with great examples. If you can light a computer scene as well as your world looks, or as well as a photograph looks, let me tell you, you're doing real good. And in that, your audience will appreciate your efforts. And when getting down to animate, again, the world's your best reference. A television and hard drive, a DVR in other words, can be indispensable in giving you the opportunity to grab whatever footage might come in handy. Sporting events, nature shows, these days they're a dime a dozen and can all be used as an opportunity to give you the best chance possible of bringing realism to your work. So get those references, real-world objects, photographs, sketches, videotape, even your friends if they'll act things out. It doesn't matter what you can get your hands on, it's all good, and indispensable when wanting to create the most believable CG work possible. If you have a character, for an example, running across your scene, grab a video camera and shoot someone running across a playground or sports field. I mean, that'd be a perfect reference to work off of. If you have a character smiling or pouting, for an example, how about using you as a reference? Grab a mirror and put a little of you into that character. I mean, you're certainly capable of making those facial expressions, right? And even if the reference you use isn't perfect, it's still going to be a much better guide than using nothing at all. So grab what you can get your hands on and get what you can out of it. You'll always do a better job using a reference to complete your work. Work smarter, not harder. If you're new to the world of 3D, it might take just a little time to get used to the idea that although you're working on a flat two-dimensional computer screen, you're actually controlling and hanging out in a three-dimensional environment. And that means you'll be manipulating not just a world that goes up and down and left and right, but also an area that goes in and out. You've got a dimension of depth, in other words, to deal with. And for many, that additional dimension takes a little bit of time to get used to, both in the way you see things and in the way you think about tackling your work. You know, visualizing things in 3D might be a little easier if you approach your computer screen in the same way you approach driving a car. You know how when driving, your ability to navigate is made much easier if you keep your eyes looking out all the windows of your vehicle and not just the one directly in front of you. Cruising down the road, you look at the entire picture, right? From all the angles and from all your windows. Well, working in a computerized 3D world ought to be approached pretty much the very same way. It's imperative that you keep all the different views in mind and in play. When you create something on your screen, that object will be displayed in a series of windows, each box being referred to as a viewport. Those viewports represent your windows into your 3D world, each pointing in a different direction, and just like with the windows in your car, each offering a different look or angle at the world you're living in. So as you begin building your 3D scenes, in order to avoid both confusion and possibly an obstacle or two in your scene that might pop up to get in your way, you got to keep your eyes not just open, but continually moving from one window to another in order to take it all in, to get all the angles. That's going to be essential. As we get a little deeper into the title, I'll be talking about the fact that 3ds Max assigns each of those dimensions, those 3 directions on your screen, with a specific letter. Those letters being X, Y, and Z. All 3D programs pretty much use the same letter way of thinking. For now, though, we're going to keep things nice and easy until we get our feet more firmly on the ground. So I'll be identifying those 3 directions for now simply as up and down, left and right, and in and out. We'll be meaning X, Y, and Z, but we'll keep those official labels off to the side until we get a little better handle on things. Now, as you start moving things around, you're going to find that Max gives you a very helpful little icon that pops directly on top of the object you're working on. That icon is called the Transformation Gizmo, or Gizmo for short. The gizmo always displays in 3 specific colors: red, green, and blue. But its shape will change, which will serve as a visual reminder as to whether you're ready to move, rotate, or scale the object you're working on. Think of the gizmo as your scene compass, as it visually displays the directions in which you can manipulate your scene objects. Once you get comfortable with how you read it, you'll find it indispensable when it comes to keeping your bearings straight, making it easy to go up and down, in and out, and back and forth. We'll be going over all of this in detail throughout the title, so for now, I just want you to get the overall concept of what the gizmo is and what it's used for. So here's what's important to know as we get going. You gotta think of your viewports as like windows in a car. And just like when driving down the road, you're gonna want to be keeping your eyes moving from one viewport window to another. That's in order to ensure that you get the big picture, that you see the entire scene, in other words. That's what's going to enable you to keep things straight in your head. The other important thing to remember is that when you do start moving things around, you're going to want to make sure to use the Transformation Gizmo to make that job a little easier. You must get in the habit of using that little guy. It's your friend. Take advantage of it. That's why it's there. You keep those 2 things straight, eyes on all the windows and making full use of the gizmo, and you'll be up and running in no time. It'll probably take a couple of times to get the routine down, but once you've got it, that's when the real fun begins, as you start creating things with all that creativity you're toting around. 3D animation is without a doubt one of the most taxing tasks you can put a computer through. Dense geometry, scenes with shadows and reflections, special effects like explosions or smoke, each can easily bring even the fastest machine down to its knees in no time. And when a machine slows down, you slow down, and nobody ever likes that. So when working in Max, it's vital that you think as smart as possible, doing whatever you can to lighten your load when you can. You gotta always keep in mind that no matter how big and bad your computer is, there's only so much processor speed and system memory, or RAM, to go around. And believe me, you'll know when you start running low on resources. The screen redraws slower, your renders take longer, heck, even saving and opening files feels sluggish. Bottom line, whatever you do will become harder to accomplish. It'd be like pedaling a bike uphill with a 100-pound backpack strapped to your shoulders. If you were able to throw that extra load off to the side, think how much easier it would be getting to the top of the grade. Well, Max works pretty much the same way. The more you strap on its back, the more you push down its throat, the tougher and slower the production process becomes. So the question is, what can you do to lighten the load? Something you ought to be asking yourself in working in any project. Let's talk about some of those things. Each of the lines you see on the teapot is referred to as a segment, and those segments control not just how blocky or smooth an object looks, more segments making the object appear smoother, but they also determine just how hard the computer has to work in order to make those computations. So the more lines, the heavier the workload. Some projects require that your objects have not just hundreds, but sometimes thousands of those little white lines. A character that would be seen close up in a feature film would be a perfect example. A high segment count would ensure that the character's surface would not just look smooth, but also deform in a more realistic way. You'll find other applications, like maybe creating a real-time video game, where the line count must be kept to a minimum in order to keep the gameplay from appearing choppy. A heavy model in situations like that would be disastrous, although geometry weight isn't quite as big a deal these days with the advances that have been made in playback hardware. What this all means is you got to realize that different applications, different jobs if you will have different requirements. Even with that though, it's going to be important that you always try to think and build as light as possible. Adding precision and detail where needed, but always trying to do so with the least amount of overhead in order for both you and the computer to work as efficiently as possible. As it pertains to working in your views, you can optimize your effort and system resources by not having all of your windows always displaying in what is referred to as shaded or realistic mode. Now, this is how Max displays the objects in your scene when using the settings as they were set coming out of the factory. Notice how Max displays only a single view in that shaded display, the other three windows being shown in what is called wireframe mode. Now, why do you think Max, by default, sets things up that way? Well, that's easy. There's less to calculate, there's less to slow things down. You gotta believe you're pushing your video card harder when you ask your software for a prettier, more detailed picture in each view. Now, with a simple scene like this, it's not a big deal. But you start building more complex scenes, and I promise you're gonna start seeing things slow down, and sometimes in a big-time way. So if you can control that stuff, and you can, you gotta think ahead, work more efficiently, building objects smarter, trying to cut down or cut back when and wherever you can. It's just a good habit to get into. You keep Max happy, and you'll find yourself buzzing through your workflow much quicker. Now there's other things you can control as you build your scenes. One is when lighting your scene, use shadow casting lights where needed, but don't go crazy. Every light in your scene doesn't need to be throwing down a shadow. Secondly, adding a bumpy or reflective surface to an object will slow things down. Now, sometimes you can't get around those rough textures and accurate reflections, but at other times, especially when things are a little farther away from the camera, you gotta be asking yourself whether you can even see those added surface elements. If you can't, it really doesn't make a whole lot of sense to be adding them in. And one of the biggest slowdowns you can force into your production pipeline is adding special effects. Things like explosions and smoke and fire. Now again, I'm not saying don't use them, but as you get more experience, you'll learn that sometimes those effects can be created with pictures and not necessarily geometry. So a few different things to keep in mind as you mull over some of the stuff you can do to help Max help you as you work on your projects. Many times those reductions can't be made. You just gotta swallow hard and take your lumps, expecting there to be a slowdown. But most of the time, there's going to be at least a few things you can do that'll optimize your speed and efficiency. Things you can definitely think about and plan on doing whenever you can. Pretty much every software program offers some sort of built-in help. Something that's readily available when you're looking for a quick answer to a problem or question. Well, 3ds Max is no different. It's got its help system. But what is different is the amount of detail and the level of depth that its help features offer. I honestly don't think that in all the years that I've been playing around on the computer that I've ever run into a help system that was as comprehensive and covered as many subjects as the help system in 3ds Max. So whether you forget how a command works or maybe just stumble across a new word or technique you're not familiar with, make the most out of what is a very thorough resource. Let's take a look at when needing a helping hand, where you go, and what you'll find when you get there. Let's say for an example that you're wanting to learn more about a brand new subject, maybe wanting to brush up on the ins and outs of animating. Up in the pull-down menus on the right-hand side, you'll access Help, then Autodesk 3ds Max Help. As the help system opens, you'll see the screen broken into both a left and right half. Over on the left, you'll see a series of tabs, each tab giving you access to the things you want to know in a different manner. The Contents tab lists things by category or individual whole subjects. So if you wanted to know more about lighting and cameras or rendering, it's all right there. As is the subject of animation. Let's say instead you wanted to look into using a specific modifier, like let's say the bend. To do that, you could click on the Index tab. Now to give you an idea of just how thorough the help system is, scroll up and down that column. That is one heck of a list. Now in looking for the bend, we'll go under Search for the keyword, typing in bend modifier. Once the words are in place, directly to the right of that, we'll click on View. Listed on the right will be everything you ever wanted to know, including an illustration of how an object would look with the bend applied, in addition to a full description of how to control the modifier's controls and settings. Also be aware that many times you may not know specifically where in the program a certain command is. Looking up at the top in the light gray area, you'll find basically the directions to where in the Max interface you'll need to go. In the case of the bend, you'll go to the Modify column, into the modifier list, then choose the command. If you ever want to find everything within the help manual that deals with a particular subject, that's what the Search tab is designed for. Let's click on that, then type in the word bend. Once you've done so, go ahead and press Enter. Max will list each and every reference to, in this case, the word bend, listing things top to bottom by the number of uses within that area the word or term is used. There's also a few other helpful options you ought to be aware of. Back in the Help menu, this time choose Essential Skills Movies. Made for individuals brand new to the program, each Essential Skills movie provides a 2 to 3 minute snapshot of a particular workflow element or technique in Max. Now, the movies aren't designed to go into the same level of detail as we'll be getting into in this title, but they do a nice job of providing a foundation to the basics of the program. There's also a handful of how-to movies that you'd like to check out. Under Help, we'll choose How-To Movies. This takes you directly to the 3ds Max Learning channel on YouTube, where you'll certainly find plenty to watch. There's also a category called the Learning Path. Let's try that. Like with the Essential Skills movies, accessing the Learning Path will take you directly to the Autodesk website. So you got to be sure that you've got a web connection up and running when attempting to look around. Here you'll find all kinds of useful information, tutorials, discussion groups, even upcoming events. And speaking of tutorials, there's a separate category for those also. Specific step-by-step instructions on a wide variety of things. Any files that might be needed to complete a tutorial can be downloaded from the Autodesk website. Now, one last thing about Max's Help. One of the advantages of running the Help feature directly from the internet is that it can be quickly updated. So don't be surprised or concerned if you ever go to access Help and the system looks just a little bit different than it did the time before. Okay, there you go with a quick once-over as to some of the Help features offered directly inside the program. The menus are easy to navigate, they're chock full of helpful goodies, and probably most important, everything's written in plain English. Take a few minutes when you can and check it out.